Hello, my name is Mr. Asprey, and this is another Edexcel paper. This is A level. It's June 2019, and it is paper 2. It's a pure paper, and some of the questions are recorded last year. Some of them are recording right now. So let's just get into it. Question 1: indices. So another indice question. I want to write everything is the same base. So here 2 would be the easiest base to use. And 4 is the same as 2 squared. And 2 times root 2 is the same as 2 to the 1 times 2 to the half. Add the powers together gives me 2 to the 3 over 2. And because it's the reciprocal of that, 1 over, it means we have 2 to the negative 3 over 2. So this is equal to 2 to the negative 3 over 2. Okay, I can write this as 2 to the 2y, because when we multiply the powers when they're bracketed like that. And now everything is in terms of 2. Oh, actually, first off, let's add these two together, because we're multiplying the 2's, so we add the powers. Perfect. And now we've got 2 to the something equals 2 to the something, so those somethings must be the same. So x plus 2y must equal minus 3 over 2. And it asks us for y as a function of x, so we need to make y the subject. So we minus the x over, and then we divide by 2. Like so. We might want to tidy that up because we don't like having a fraction in a fraction. So what we could do is times top and bottom by 2, which gives me this. I think that looks much neater. Lovely. Question number 2, it says the speed of the small aircraft is measured every 5 seconds. Okay, and here's the time and here are the speeds. So it says estimate the length of the run rate used by the jet to take off. Right, so if I were to graph this just quite quickly, we'd have 0, 5, 10, 15, 20, 25, and we'd have a speed of like 2, 5, 10, 18, 28, 42. In fact, it would be much more of a curve than that, wouldn't it? So it would look something like this, let's say. And what we could do to find the area, well, is we could use the trapezium rule. And why would we want to do that? Well, the area under a velocity time graph is the distance travelled, so that's what we're trying to estimate. So we're going to use the trapezium rule with a height of 5, because the gap between them is 5. So the trapezium rule, the area is equal to height over 2 multiplied by the two end values, which are 2 and 42 added together, plus 2 times all of the middle values, which are 5 plus 10 plus 18 plus 28. Okay, great. So I'm going to put that on my calculator now. Voila! So I put that into my calculator and I get an estimate of 415 meters. Okay, given that the jet accelerated smoothly in these 25 seconds, explain whether your answer to part A is an underestimate or an overestimate. Okay, well, this curve is a convex curve. It curves upwards. So the trapeziums will be slightly larger than the area that we calculated, which makes it an overestimate. So it is an estimate. It doesn't say that you need to, it does say it's explain. So overestimate as the trapeziums are greater than the area under the curve. Okay, and you can see that best on this final one here. If I try and exaggerate it, the curve looks like that, like a convex curve, and the trapezium will be like this. So you'll see that the trapezium will cover more area than the convex curve. Okay, question number 3, and we've got a sector, and it says that a student attempts to find the area of the sector below, and they've done this working. Explain the error made by the student. Okay, well, the error is that they've not used radians. Okay, so the error is angle measured in degrees, not radians. Okay, write a correct solution. Okay, well, the area is equal to 1/2 times r squared times by theta, but we need to measure theta in radians to use this formula. So in order to convert into radians, we would need to do 40 multiplied by pi over 180. I always remember it as if you want to convert into radians, then you're going to multiply by pi, so pi's on top. And if you want to convert out of radians, then you would times by 180 over pi. So pi's on the bottom, so you're kind of cancelling out the pi part. Okay, so what does this give us? This gives us 4 pi over 18, which is the same as 2 pi over 9. So the area is 1/5 times, 1/2, of course, using the formula, times 5 squared times 2 pi over 9. So I'll put that in my calculator. And there we go. So we get 25 over 9 pi here. And then I might convert that into a decimal, which is 8.72, and that would be centimeters squared. Bosh. Okay, here we have parametric equations, and it says that they meet the circle C2 with this equation at 4 distinct points as shown. Given that one of these points lies in the 4th quadrant, 1, 2, 3, 4, find the Cartesian coordinates of S. Okay, so we need to solve simultaneously. So what we'll do is we will sub these parametrics into this circle. So we're going to get x squared, which is going to be 100 cos squared t. Y squared is going to be 16 times 2 is 32 sine squared, and that's equal to 66. Okay, next we want to get it all in terms of either cos squared or sine squared. So let's just replace the cos squared with 1 minus sine squared using our identity, classic identity. Cos squared plus sine squared equals 1. Let's expand out, which gives me 100 minus 100 sine squared t plus 32 sine squared t equals 66. So this is going to give me minus 68 sine squared t minus the 100 over to there gives me minus 34. Great, divide through by minus 68 and I get sine squared t is equal to just 1/2. And that means that sine t is equal to plus minus the square root of a half, which is a quarter. Sorry, not a quarter. What am I talking about? It's just the square root of a half, which is plus minus 1 over the square root of 2. Okay, so let's find the t values then. Well, actually, in fact, we don't need to find the t values because we can just go directly to our equations for y. So what do we need? We need it to be in this quadrant here. So I need the y to be negative. So my sine t, which I'm going to sub into the y, must be the negative one. So my y value will be 4 times root 2 multiplied by the negative 1 over root 2. Oh, sorry, yeah, perfect. Okay, so these cancel. So we just get that y is equal to minus 4. Okay, now how are we going to work out the x-coordinate? Probably the quickest way would just be to sub it back into this. Because y is minus 4, it means y squared is going to be 16. Which means that x squared will be 50. So x will be plus or minus the square root of 50. Which is plus or minus 5 root 2. But which one do we need? Do we need the plus or the minus? Well, it's in this quadrant where the x is positive, so we need the positive one. So my overall coordinate for s is positive 5 root 2, negative 4. Question 5. We've got this diagram here, and it's basically explaining that integration is an infinite collection of rectangular strips where the width tends to 0. So this notation here basically means integrate between 9 and 4 root x dx, and that's it. Okay, so to integrate, I'd want to write it as a power of x. Then I will up the power by 1 to get 3 over 2. Divide by the new power. Dividing by 3 over 2 is the same as timesing by 2 over 3. And then I'll need to sub in 9 and 4. The power of the 2 on the bottom means to root. So root 9 is 3, then cube it is 27, divide it by 3 is 9, times it by 2 is 18. 4 rooted is 2, cubed is 8, 16 over 3. This is the same as 54 over 3 minus 16 over 3. Which is equal to 38 over 3. Okay, question number 6, and we have a piecewise function split up into 2 parts. It's asking us to find g of 0. Okay, so the first thing I'll do is find g of 0. And I need to sub it into the top part of the function because that's where all the x values are less than 2 and 0 is less than 2. So I get 0 minus 2 squared plus 1, which is of course the same as 4 plus 1, which is 5. So now for me to find g of 0, that's the same as doing g of 5. Subbing the 5 value that we got in above back into g. And this gives me 5 minus 2 squared plus 1, which is 3 squared plus 1, so it's 9 plus 1, which is 10. Great. Find all the values of x for which g of x is greater than 28. 28. Okay, well, I mean, let's just use the graph to help us. Imagine if 28 was there, then this part of the graph is going to be greater than 28, and also this part of the graph is going to be greater than 28. And also the fact it being a 4-mark question suggests that we're going to have to solve both halves of the piecewise function in order to find all the bits which are greater than 28. So let's get started by saying, what about if this bit was greater than 28? Okay, so if that's the case, then we could say that x squared minus, let's expand this bracket, 4x plus 4 plus 1 is greater than 28. So x squared minus 4x plus 5 minus 23 is greater than 0. Okay, so that is definitely not going to factorize. So what I'm going to do is I'm going to use my calculator to find the roots of that equation. So I'm going to go to equation, polynomial, degree 2, 1 minus 4 minus 23. Okay, yeah, so that has x values of 2 plus 3 root 3, and of course the next one must be 2 minus 3 root 3. And let's just quickly look at the graph. You can see here that this x value that we want is definitely going to be the one which is less than 0. There's definitely a negative value here. This is definitely a negative value. So this is going to be the 2 minus 3 root 3 part of the graph. Okay, so that's the one that we want. So that therefore tells us that we want x to be less than 2 minus 3 root 3. Because of course we want all the bits which are going off to the left of that particular critical point. Okay, right, now to find this critical point here. And that will be when the other function, or the other half of the function should I say, is greater than 28. So that's when we have 4x is greater than 35, so x is greater than 35 over 4. And that's legit, so that means that point there is just 35 over 4. So we're looking at all the points to the right of that, so we do want all the points which are greater than. So my final answer will be written in set form. Why not? They don't ask us for set notation, but I'll just do it anyway. Less than 2 minus 3 root 3. Union, because these are two separate parts. You can tell by the highlighted yellow bit that these are two separate regions. X with x is greater than 35 over 4. Okay, so they haven't asked me for set notation, but there you go, I've just given it because they do often ask for set notation. Hopefully that's useful. Okay, great. Moving on to the next bit then. So the next part C, tells us or asks us that we have a function h of x, which is defined as that's the top half, just a bit of this top bit, yes. Explain why h has an inverse but g does not. Okay, so h of x is a 1-to-1 function, and therefore has an inverse. I know that because you can just tell by the graph h of x will be h of x is just a bit to the left of that junction point there. So you can see that's 1-to-1. Every x value has a unique y value. Whereas when you had the two bits together, i.e. g of x, then not every x value, or not every y value has a unique x value. You can see here, for example, there'll be two x values which give the same y value. Then you could just say, however, g of x is not one-to-one. Okay, in fact, it is many to one. Just a bit of added information. Okay, and then finally it says solve this equation. Okay, let's just grab some more space. So if the inverse function spits out an answer of -1/2, then it means that the value of -1/2, when I sub it into h, should get me back to x. So maybe I didn't explain that very well. But at the moment what we had is we have x is what we're trying to find, and it goes into the inverse function, and that gives me -1/2. So by the nature of inverse functions, if I sub it into the original function, I should get back to x. So rather than working out the inverse function and then solving it equal to -1/2, the most efficient thing to do is just to sub -1/2 into h of x, and that will give us the x value that we so desire. So doing that means that I will just have -1/2 minus 2 squared plus 1, which is the same as -5/2 squared plus 1, which is the same as 25/4 plus 1, which is the same as 29/4. Fantastic. Okay, this is a modelling question using straight lines. Lots of text. Don't enjoy these types of questions. On any day, the total cost of the factory, Y pounds of making X bars of soap, is modelled to be the sum of two separate elements. A fixed cost, a cost that is proportional to the number of bars of soap that are made on that day. Write down a general equation linking Y with X for this model. Okay, so the total cost, Y, is equal to a fixed cost, let's call that C, plus a cost which is proportional to the number of bars of soap. So as X increases, this cost increases as well, so it's K multiplied by X, where K is the constant of proportionality between the overall cost and the number of bars of soap that are made. The bars of soap are sold for £2 each. On a day when 800 bars of soap are made and sold, the factory makes this profit. On a day when 300 are made and sold, the factory makes a loss of this. Using the above information, show that Y is equal to blah blah blah. Okay. Okay. It's quite difficult to get your head around this, but let's just work through it. And we know that when 800 bars, so 800, we sell them for £2 each. So this is how much money we make. Well, this is how much money we get in revenue, and the profit is 500. So how much of this must be cost? Well, it must be 1100 in order to allow £500 of profit. So Y is equal to 1100 when X is equal to 800. And if we have 300 bars times by 2, that's £600. And we make a loss of £80. So how much cost would there have been? There must have been 680 cost in order for us to make a loss when we only return 600. And that happens when X equals 300. Okay, so we've got essentially two pairs of coordinates, so we can form a straight line. So the gradient, which is k in this case, is the change in the y, so 110 minus 680, over the change in the x, which is 800 minus 300. So we put that into our calculator, and we divide that by 500 on the bottom. So great, we get k is equal to 0.84. And then in order to find c, we would just do y, we would just sub in, let's sub in 1100 is y, k is this, x is this, so plus c. Let's rearrange to find c by doing 1100 minus 0.84 times 800, and we get 428. Okay, perfect. So that's it, and then it just says show that, so I'll just put it all together. There we go. Okay, with reference to the model, interpret the significance of the value of 0.84. Okay, well, we were told before that there was a fixed cost, so that's the constant C, and we were told that it was proportional, there was a cost that's proportional to the number of bars of soap, which is K. So that means this is the cost of making 1 bar of soap. Well, actually, it's the cost of making 1 extra bar of soap. It's probably a bit more correct. Yeah. Okay, and then next, assuming that each bar of soap is sold on the day it's made, find the least number of bars of soap that must be made on any given day for the factory to make a profit on that day. So what we would need for that is we will need that the revenue, which is 2 times the number of bars of soap, because remember that's how much they cost, that's how much we sell them for, that needs to be greater than the cost, which is 0.48x plus 428. Okay, it's just solving this equation. It's going to give me 1.16x is greater than 428. So x needs to be greater than, let's divide this, 368.9. So the answer is that x is equal to 369 for the least number of bars they need to make. Okay, question number 8, and this is looking very tasty. I like the look of this. Okay, so whenever we have a summation, when it's not obvious kind of what is going on, it's a good idea just to write out the first couple of terms. So here we're starting with r equals 4. So when we have r equals 4, we have 20 multiplied by a half to the power 4. We're summing, so we're adding, and the next term will be 20 times by a half to the power 5. And then 20 times a half to the power 6, and so on forevermore, because it's up to infinity. Okay, so the first term, just using my calculator, will be 20 multiplied by a half to the power 4. Okay, so that'll be 5 over 4. The next time, we're just timesing that same thing by a half. So that's going to be 5 over 8. And then once again, we're timesing this next one by half, so it'll be 5 over 16. And again, that's going to go on forever. So this is a geometric series because each time we're timesing by something. So the r value is what we're timesing by, and that is the common ratio, and in this case it's a half. We're timesing by a half each time. A is the first term, which is 5 over 4. So I think we're good to go now. So we can write that the sum to infinity of 20 multiplied by a half to the power r is equal to our summation formula, which is 1 over a minus r. That's the sum to infinity. You're given that in your formula booklet. So that's 1 over 5 over 4 minus a half, which is the same as 1 over, a bit lazy to be honest, probably, that's very lazy, that's extremely lazy, what am I doing? That is of course 3 over 4, which is 4 over 3. Okay, perfect. Right, moving on to part 2. Okay, so in exactly the same format, I've got no idea what's going on here. I mean, that is just horrendous. Who knows what on earth that is? So what we're going to do is we're going to write out the first term. This time n is 1. It's a show that question, so I'm just going to ignore the fact that it equals 2. I'm not going to look at that. I'm just going to look at the left hand side to see if we can show that it equals 2. Okay, so n is 1. So I do log base 5. When n is 1, I get 3 over 2. We're summing, so I need to add on the next term, which will be log base 5. N is 2 this time, so we get 4 over 2. 4 over 3. Okay, good. And then again, I'm just going to write out a few terms just to get an idea of what is going on. And that's going to go all the way up to the last term, which is when n is 48. So I get log base 5 of 50 over 49. Okay, and what happens when we add logs? We can rewrite them, can't we? We can rewrite them as one single log with all of the inputs multiplied together using our log rules. So we're going to get this. And the next one will be 6 over 5. And then we'll go dot, 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 all the way to the last one, which one will be, again, we'll have 49 over 48. And then the final one will be 50 over 49. Okay, and now we can see that this is going to cancel out nicely. Oh, it's beautiful. What a beautiful question. So the 3 and the 3's will go, the 4's and the 4's will go, the 5's and the 5's will go, the 6 will go with the 6, which is going to be there. Carrying on, there'll be a 48 before that one, which will cancel with that 48, and there'll be the 49 and the 49 will go. So we are left with log base 5 of 50 over 2. So the last one here and the first one there. Beautiful. And this is of course log base 5 of 25, and 5 to the power 2 is 25, so log base 5 of 25 is 2. And we have shown it. Double check by revealing the answer. Ta-da! Bosh. Okay, question number 9. And what have we got going on here? Blah de blah de blah. The graphs of d versus v and log d versus log v were plotted. Lovely. Here's the results. Explain how figure 6 would lead to the engineer believing that the braking distance should be modelled by the formula blah de blah de blah. Figure 6. Okay. Well, strange for 3 marks, but it's because it's a flat line. So what we could do is we could say that d is equal to k vn. We can log base 10 both sides, which gives me a log base 10 of k vn. We could split that log up, so we get log k plus log vn. And then we could write that this is log 10 of k plus log base 10 v, and bring the n down to the front like that. And then finally we could write it so that the variables, so that's log d and log v, are lined up so it looks really similar to a y equals mx plus c. So this is the y variable, and this is the x variable. And then we have m is the gradient plus c is the intercept. Okay, so then we can write that plotting log d against log v would result in a straight line. And we can say that with n equal to the gradient and log base 10 of k equal to the intercept. Okay, right, I think I've done enough there to get the 3 marks. I've basically explained exactly why these formulas, when applied with the logarithm, will give you a straight line graph. Okay, so it says using the information in figure 5 with k is equal to this, find a complete equation for the model giving the value of n to 3 significant figures. Okay, well, we can just sub in the point then, because that's all the information that we get from figure 5. So the d value is 20, so we can say 20 is equal to k, we're told what that is. V, well, the v value is 30 in this case, and then that's to the power of n, which we don't know what that is. Okay, so what we could do is we could do, I'm going to need my calculator for this, we could do 20 divided by 0.017. Okay, great, and that gives me 1176.47, and that's equal to 30 to the power n. And then in order to find n, we can take log of base 30 of that value, and that should give us our value for n. So doing that, I'd press this button here, log base 30 of that final answer, and we get 2.07, and that's the 3 significant figures, so it's 2.08. That's the value for n. Okay, and then let's just get rid of this calculator so we've got a bit more space. Yeah, big part of the question, it does say not just find n, but it also says find a complete equation for the model. So that basically means I need to write out what the equation actually should be. So in that respect, it is d is equal to k, which we know already, v, which is a variable, and n, which is, we worked out is 2.08. So that is the final answer that they're looking for. Okay, great. Okay, Sean is driving his car at that speed, 60 kilometers per hour. In wet conditions, he notices a large puddle in the road. It's 100 meters ahead of him. It takes him 0.8 seconds to react before applying the brakes. Use your formula to find out if Sean will be able to stop before reaching the puddle. Okay, so first off, the distance he travels before applying the brakes will be distance is equal to speed times by time, of course. So the speed is 60, but that's in kilometers per hour. So what we need to do to convert it to meters per second, we need to times by 1,000. That will get it into meters, and then divide by 60 times 60 in order to get it into seconds. And then we'd multiply that by 0.8, because that's how long it takes. So if we were to do that, then that will tell us how far he'll travel before applying the brakes. Okay, so he's travelled already 13.3 meters. Okay, and now we can use our formula to work out how far he will travel once the brakes have been applied, because he's going at 60 miles an hour, and the end value we worked out already, didn't we? Yes. So let's put that into our calculator. Not 60 miles an hour, it was kilometers per hour, before I get slammed in the comments. Let's go point. Okay, right, so it's going to be close. 84.92. So total distance is going to equal, I need to add on that, what was it, 40 over 3 exactly, wasn't it? Okay, right. Okay, thankfully he just about makes it. So he will stop in time. He will stop in time as 98.25 is less than 100 meters. Job done. Question 10, let's go. Vectors. It says the point C is such that OC is equal to 2 lots of OA, and that's why they've left a gap at the top of the question, so you could draw it on like this. A bit of a perfectionist, that wasn't nice enough. That'll do. Okay, so C goes there. The point M is the midpoint of AB. That's no problem, that goes there. And the straight line through C and M cuts OB at the point N. Okie dokie. So that's N. Given that OA is A, okay, so I draw a little A there, going in that direction. And this will also be A because, remember we said that OC was twice OA. And OB is B. Okay, so B goes along there. Find CM in terms of A and B. Right, so I need to go, okay, I need to go from C down to M. Okay, so the first thing I'm going to do is I'm going to get an expression for A to B. So A to B is minus A, because I come down this way. So it's minus A, and then we plus on B. Okay, great. Now that's helpful because I can get an expression for A to M, because I know that M is halfway along that line. So it's a half of, and I can write it like this, B minus A, rather than minus A plus B. Just a bit nicer. Great, so now I can find C to M, because C to M means I need to go minus A and then plus AM. So it's minus A plus a half B minus A, and that is equal to how can I write that? I can write that as a half of b minus 3a. Just double check, does that work right? Yeah, that's good. Okay, part B. It's just nasty. It says show that O to n is equal to this, where we have this like lambda value. So O to n is from here to here. And obviously we don't know how far along that value will be. So what we can do though is we're going to have to go that kind of long way around, aren't we? And what we're going to have to do is do 2a to get up to here, which is good because we've kind of got 2a here, so that kind of makes sense. And then we're going to have to go down cm, but we're going to have to go a bit further than just to c, just to m. We're going to have to multiply cm by some constant. So from get to there, we're going to call that lambda cm. So you know you have to times cm twice. It doesn't look like it, but maybe like lambda's like 1.5 or something. Okay, so therefore we can say that O to n is equal to 2a plus lambda cm. So this is 2a plus lambda, and cm we said was 1/2 b minus 3a. Okay, so this is 2a, and then if I expand this out, I'm going to get 1/2 lambda b, and I'm going to get minus 3/2 lambda a. Okay, so let's factorize out an a, and we have 2 from this term, and we have minus 3/2 lambda from that term. And if we take out a b, we don't need to take out a b actually, do we? It's just 1/2 lambda b. Okay, and that is done. That's a really nasty question because it should really explain kind of what lambda is. You have to guess there. Okay, hence prove that O to n and n to b is in the ratio of 2 to 1. Okay, well, what I've noticed from this is that well, O to n is along this line, and it's along exactly the same line as O to b, which is just the vector little b. So therefore the vector O to n must have 0 a component. It must only be a certain amount of b, because it's on the same line as the vector, which is just b. So therefore we can say that 2 minus 3/2 lambda must equal 0, because that's the a component of O to n. This part here. So this tells us that 2 must equal 3/2 lambda. So 4 is equal to 3 lambda. So lambda is equal to 4/3. Okay. So what does that mean then? Well, that means that O to n is actually, well, 0a, as we just said, and the b value is 1/2 times by lambda, which is 4/3, lots of b. So that's the same as 2/3b. So that means that O to n is 2/3 of the way along of b, which means the final part from n to b must be 1/3 of b in order for the whole line to add up to b. So therefore that means that n to b, like I said, must be 1/3 b. So therefore O to n dotted with n to b, or ratioed, sorry, is the same as 2/3 b dotted with 1/3 b, which is the same as 2/3 to 1/3, which is the same as 2 to 1. Done. Another one. Number 11. Find by firstly taking logarithms the x-coordinate of the turning point of C. Okay. So, well, I guess what they're saying here is that first off I need to take logarithms. So it's nice of them. Let's take the natural logarithm of both sides. So ln y is equal to ln x to the x, which of course means that I can bring the power down, like so, and now I can differentiate. So differentiating ln y will be 1 over y, because ln differentiates to 1 over the variable, but because we're differentiating with respect to x, and that is a function of y, that is implicit, which means we always need to multiply by dy by dx. This is a product rule now. So what I do with a product rule is I split it into two parts, of course, and then I think about differentiating the yellow, which is 1, and then leaving the blue alone, and then we plus leaving the yellow alone and differentiating the blue, which differentiates to 1 over x. Okay, so we get 1 over y dy by dx is equal to ln x plus, that's just 1. Okay, great. So this tells me that dy by dx is equal to ln x plus 1 multiplied through by y. And if I want to find the turning point, then, well, actually, sorry, let's just get rid of the y now, because we know that y in this graph is equal to x to the power x. Perfect, we've differentiated it. And now we need to set it equal to 0 to find the turning point. So we're not going to get a 0 come out of the x to the power x, but we will get 1 come out of this bracket here. So ln x plus 1 we need to equal 0, which means ln x equals minus 1. So taking e of both sides, this gives me x is equal to e to the minus 1. And then we need to find the, oh, it just says the x coordinate, so I think we're done. Perfect. Okay, next part, B. It says show that alpha, which is the point which has a y coordinate of 2, show that it is between 1.5 and 1.6. So that means if I sub in x as 1.5, then I should get below 2. And if I sub in x as 1.6, I should get above 2, which would mean that it's in between. Okay, so in doing so, I will write x equals 1.5, gives a y value of 1.5 to the 1.5, which is equal to, I'm going to use my calculator for this, of course, 1.5 to the 1.5, and that gives me 1.84, and then of course what I'll do next is I'll do 1.6 to the 1.6, and I expect to get something which is above 2, which it is. So that is great. Let me just write that down. I know you can't see it because the calculator's in the way. That's annoying. Calculator go away. There we go. Okay. And then we can say, therefore, as the function is continuous and the values are below and above 2, 1.5 is less than alpha 1.6. That does it for me. Pretty sure I've covered all bases there with a little statement after you've proved something. Happy with that. A possible iteration formula that could be used in an attempt to find alpha is given as this. Thank you very much. Use this formula with x is equal to 1.5 to find x4 to 3 decimal places. Okay, well, I mean, all I need to do then is just use my calculator to do this. So what I will do is I will type in my first answer, x1, and I'll press equals. And then what I will do is I will type in the formula as 2, the first x value, which is now my answer, to the power of 1 minus the answer. So I press X, and this gives me my x2 value, which I don't know if I need to write down as such, but I'm a perfectionist, so I'm just going to write it down. x3, press equals, that gives me 1.466, and then I press equals again, and I get x4 is equal to 1.673. It says describe the long-term behaviour of x to the n. Okay, well, I mean, if I just press it a couple of times, it looks like it's going to, well, there you go, look, it's fluctuating between 1 and 2. You can see it clear as day. So you just write that down. So this is my answer for part C, and then for part D we can say x to the n oscillates between 1 and 2. Bosh. I like that question, that was nice. Okay, question number 12, and what a lovely question. It's actually been my last question tonight because 13 and 14, Mr. Asprey of 2023 has already recorded those ones. So let's bosh this one out and then I will say my goodbyes. Right. Ooh, that is nasty. Okay. Oh, okay. Right, sorry, just talking to myself. You're adding two fractions, you're going to want a common denominator, aren't you? So let's multiply this one by cos, so that I have sine and cos on bottom, and then let's multiply this one by sine. So once again, I have oh my gosh, this is magical. I can see what's happening right now. So I have this. Okay, so what we have is we have cos 3 theta cos theta plus sine 3 theta sine theta all over sine theta cos theta. Okay. And what we could do up here is we could say as sine 2 theta by our double angle formulas is 2 sine theta cos theta. It means that 1/2 of sine 2 theta is equal to sine theta cos theta. Right, so that's the denominator sorted. And we also got this cheeky little triple angle formula here. So we know that cos of theta plus alpha, cos of theta minus alpha is equal to cos theta cos alpha plus sine theta sine alpha. So that is your compound angle formula for cosine. So therefore we can say that cos of 3 theta minus theta is equal to cos 3 theta cos theta plus sine 3 theta sine theta. And that's exactly what we got on the numerator. So we got the denominator here, and we've got the numerator over here. So we could say this is equal to, well, on the top it's cos 3 theta minus theta, and then on the bottom we have 1/2 sine 2 theta. Okay, so dividing by half is the same as timesing by 2, so the 2 can come to the top, and that's cos 2 theta when I do 3 theta minus 1 theta, and that's over sine 2 theta, so this is the same as cot 2 theta, because cos divided by sine is cot, 1 over tan. Beautiful! Love that. Okay, and now the final part is asking me to solve for this given range, this same thing which we've just already shown is the same as 2 cot 2 theta is equal to 4. So essentially I'm just solving cot 2 theta is equal to 4. Oh, sorry, 2 cot 2 theta is equal to 4. So part B, 2, oops, I wrote cos there, steady. 2 cot 2 theta is equal to 4, which means that cot 2 theta is equal to 1/2. Oh, no. Oh, I'm just too excited. I love this question so much. I'm rushing and I'm making mistakes. Divide by 2 is equal to 2. Okay. And cot is 1 over tan. So cot is the reciprocal of tan. So let's take the reciprocals of both sides. And that gives me 1/2. Lovely. Okay, so 2 theta is equal to the inverse of tan of 1/2. We're in degree mode because the question asks for degree mode. And we are going to do this. And we are going to get my first value for 2 theta. And that's equal to 26.57. Okay, just a quick check of that range again. 90 to 180. Okay, so 90 to 180. Well, as soon as I've done tan to the -1 on my calculator, I'm going to add on 180, because that's how we find the second solution for tan. That gives me 206.57. And then I'm going to find the next solution. I'm just too excited. Okay? And in fact, what I could do is I could find the one after that as well if I wanted to. And you do that by adding on 360 to your first value and your second value. Okay, you do that for every trig function. Once you found the second one, which is different for each. Tan is 180 plus, sine is 180 minus, cosine is 360 minus, but once you found the second value, you can then just go ahead and add on 360 to your first and your third value. So in this case, we're going to get this. Right, I've gone too far, because when I divide through by 2, this first one is going to be 13, so that's not in the range. This one, however, is going to be good. It's going to be 103.28. Let's just go with that. So 0.3 when rounded. Okay, good. And this one is going to be over 150. it's going to be 100, it's going to be over 190, so that one's no good either. So this is the only solution. What a question. And if you did enjoy this video and you did enjoy this question, then please do like and subscribe, and I will see you later. Bye for now. Question 13, we've got a cylinder and a hemisphere, and it says the manufacturer produces a storage tank. The tank is modelled in the shape of a hollow cylinder. Yeah, blah, 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 blah. Blah, blah, blah. Blah, 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 blah. Blah, 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 blah. The volume of the finding, something useful. The volume of the tank is 6 meters cubed. Show that according to the model, the surface area of the tank in meters squared is given by. Okay, surface area. Well, the surface area of the hemisphere on top, let's call that part A, is going to be 4 pi r squared divided by 2. So that's 2 pi r squared. And the curved surface area of the cylinder is going to be 2 pi r, which is the circumference around, multiplied by the height. Okay, great. And I assume we also need the base as well. Let's call that C, and that's just a circle, so that's pi r squared. Okay. We also know the volume of the tank is 6 meters squared, so we're going to use that as well. So let me just get an expression for the total surface area first. Add these two together gives me 3 pi r squared plus 2 pi r times h. So we need to remove the h. So we use the volume information. So the volume is equal to the volume of the cylinder, which will be base area times by height, plus the volume of the hemisphere, which is half of 4/3, so 2/3 pi r cubed. Okay, great, and we're told that the volume is equal to 6. So what we'll do next is we will make h the subject by rearranging this. So we're going to get 6 minus 2/3 pi r cubed is equal to pi r squared h. We're going to divide by pi r squared to get 6 over pi r squared, and then minus 2/3 r. Okay, so now we've got h in terms of r. We can sub that in over here. So I will do that here, and we'll get 3 pi r squared plus 2 pi r multiplied by 6 pi r squared minus 2/3 r. That is horrendous. Okay, so let's simplify that, and I will do that. I'll get some. Let me get me some more space. That's better. Okay, right. 3r squared, multiply this out, is going to give me 12. Pi's will cancel. It'll be an r on the bottom, and then multiply this through. We'll get a 2 times 2, which will be a 4 on top. There'll also be a pi on top, and there'll be an r times an r, which is an r squared, and that will just be over 3. Okay, so how many pi r squares do we have? We have 3 minus 4/3, which gives me 5/3. So great, we get 12 over r plus 5/3 pi r squared. And that is QED. Right, part B. It says, use calculus to find the radius of the tank for which the surface is a minimum. So that means we need to differentiate this surface area with respect to r. So we get the derivative of a with respect to r is equal to, this is 12r to the minus 1, and when I differentiate that I get minus 12r to the minus 2, and then when I differentiate 5 over 3 pi r squared I get 10 over 3 pi r. And I need to set that equal to 0, and the first thing I would do would be multiply through by r squared, which gives me just minus 12 plus 10 over 3 pi r cubed equals 0. So solving for r cubed, will be positive 12 divided by 10 over 3 pi. So it'd be 12, and then I'll divide that by 10 pi over 3, and that will be my value for r cubed. And then I will cube root that, and I'll get an r value of 1.046. Okay, great. And then it asks me to calculate this minimum surface area, giving your answer to the nearest integer. So I just need to sub that back into the area formula, and the area formula is this one here. So I'll just sub that in, and I'll write 12 over 1.046 plus 5 over 3 pi 1.046 squared. And for the sake of the video, I'm not going to bother working that out. I'm just going to say the answer is 17.20, which gives me 17 to the nearest integer, meters squared. Don't forget your units. Lovely. Okay, we need to use this substitution, so integration by substitution, and I'm going to write it down here. U is equal to 4 minus root h. I don't like having square roots when I do integration by substitution, so I'm going to get rid of that. Let's make the root h positive as well by moving it over to that side, squaring both sides, and then let's differentiate with respect to u. So this gives me dh by du is equal to 2 comes down to the front, write out the bracket, drop the power, and then times by the derivative of the bracket. With respect to u, the derivative of that would be minus 1, so there'll be a minus there. Now I can make dh the subject, and we have an expression for dh. Perfect. So now let's sub back in. So we have the integral of dh was on top, which is going to be minus 8 plus u when I multiply out, over the expression on the bottom is just a substitution, so that's u. Great. We can split this up to minus 8 over u plus u over u. Oh, whoops, apologies. Should be 2u when I multiplied out the brackets. That's plus 2 du. So this gives me minus 8 ln u when I integrate, plus 2u plus a constant c. And we need to replace the u's with 4 minus root h. So also when you ln, you should put a modulus sign around them like that. So the modulus of, it was 4 minus root h plus two lots of 4 minus root h plus c. And we're not quite good. That's minus 2 root h there. Okay, no, not to worry. We can just multiply out that bracket and then change our constant. So when I multiply out this bracket, I do get minus 2 root h. I also get plus 8 plus c. And we can just replace this, do a constant swap, call that k, where k is equal to 8 plus c. And we're good. Okay, a team of scientists is studying a species of slow-growing tree. How exciting. The rate of change in height of a tree in this species is modelled by the differential equation. Okay, so what we're going to need to do, find, according to the model, the range in heights of the species, of trees of this species. Okay, so the range in heights, well, we need to find the maximum height, and we'll do that when the derivative is equal to 0. So we need this to equal 0. Now, this part, that can't equal 0. So it's going to have to come from this part. So let's set that equal to 0. So part B, we have 4 minus root h equals 0. So that means that root h is equal to 4. So h is equal to 16. Okay, so that is the maximum height. So therefore, we can say that the range is anywhere between 0 and 16. Okay, next, it says one of these trees is 1 meter high when it's first planted. Okay, so t equals 0, h equals 1. According to the model, calculate the time this tree would take to reach a height of 12 meters, giving your answer to 3 significant figures. It's a 7-mark question, so we have to solve this differential equation. And we will do that by separation of variables. So I'm going to multiply, I'm going to divide through by the 4 minus root h on that side, and I'm going to multiply through by the dt on the other side. So I have this, and that's perfect because we already know what this left hand side integrates to from part A. This integrates to, it was minus 8 ln 4 minus root h minus 2 root h plus k. And this integrates to, well, we could take the 1 over 20 out, and when I integrate this with respect to t, I just get the same thing. Sorry, I don't mean the same thing. I up the power to get t to the 1.25, and then I divide by the new power. And I also get, well, I don't get plus, I don't get a constant because I've already got my constant on this side. But it doesn't matter which side you put it on. Okay, next I'm going to sub in those initial conditions, which was t equals 0, h equals 1. That's going to give me minus 8 ln of h is 1, so that's ln 3, minus 2, plus a constant is equal to, and t is 0 here, so we just get 0. Okay, so that tells me that this constant k is equal to 8 ln 3 plus 2. Okay, and now the question asks us to calculate the time this tree would take to reach a height of 12 meters. So I need h to equal 12. So let's just rearrange this as best we can. And I'm going to sub in h as 12. K we said was plus ln, so 8 ln 3 plus 2. And this is the same as 1 over 20 divided by 1.25. So that's 1 over 25 t to the 0.25. Okay, I'm going to skip through this. I'm going to put that into my calculator and see what it comes out with. Okay, so I've just put that into my calculator and I've got 8.85. And as I was doing that, I realized that I didn't write that correctly. That is the power of 1.25, not 0.25. Okay, so that's good. We then multiply through by 25. Whoops. We get 221 is equal to t to the, that's 5 over 4. So to find t, I would need to raise this to the power of 4 over 5. Just reciprocal powers when you want to move it to the other side. So I'll do answer to the power of 0.8 is 4 over 5. Great, and I get t is equal to 75. And that's 0.2, and that is years.